Hey everyone, this is Mrs. Morgan with Chapter 11, Lesson 1, Inverse Variation. We're going to determine whether tables and equations represent inverse variation, and then we're going to write and graph inverse variation equations. What is an inverse variation? It's a situation where the product of two values remains constant. And it looks like either xy equals k or y equals k over x. X, y, and k are all non-zero. An example situation, say you're going to run a 1-mile race. Well, the faster you run, the shorter your time is. Or, the slower you run, the longer your time. But either way, you're going to run 1 mile, so that stays constant. We're going to determine whether each table or equation represents inverse or direct variation, and we're going to explain why. And just a reminder, direct variation, also known as proportional equations, look like y equals kx, and this is back from chapter 3. So, looking at table 1, x is 6 and y is 3, x is 8 when y is 4, x is 10 when y is 5. This is a direct variation because each time our y is half of our x. In number 2, when I look at my table, 1 and 12, 2 and 6, 3 and 4, every time my x times y is 12, which is an example of inverse variation. We're going to determine whether each table or equation, so now we're going to look at some equations. And negative 2xy equals 20, well, it does look very close to our xy equals k. We're just going to divide off negative 2, divide off negative 2, and our xy equals negative 10, which is inverse. I'm going to see if I can't do this any faster just by typing. Yep. So inverse. Looking down here, I'd say we're probably a bit closer to our y equals kx. It's just that right now our constant is over with the y. So we know there's a 1 in front of x. We can divide both sides by 0.5. And these will cancel. That'll leave us with y. And 1 divided by 0.5 is actually 2x. And this is a direct variation. Okay. We are going to assume that y varies inversely as x, so our xy equals k. We're going to write an inverse variation equation that relates x and y, and then we're going to graph. So the problem's actually going to look like this. Y is 5 when x is 12. And what we're going to do is we're going to take our general form, xy equals k, and we're going to plug in 12 for x and 5 for y, and we get our k is 60, And so if we plug that back in, our equation that we're going to want is this xy equals 60. So that's the first part where we write an inverse variation equation. Now we're going to graph. So your hint is that we're going to pick numbers that multiply to 60, and I've kind of laid out a couple of patterns that you can follow if you'd like. 6 and 10, -6, -10. I pulled positives and negatives because you're going to see a very interesting shape to this graph. And you'll also notice that I scaled by 3's in your graph. So if I plot the point 6, 10, and -6, -10, then I plot over 10 and up 6. You do not need to listen to me plot points. And you might be able to see it right now. You certainly will in a minute, that our swoosh is back. We get our swoosh in 2 directions. So our swoosh is back. Okay. No. All right. We have a product rule for inverse variations. If we have 2 solutions, x1, y1, x2, y2, if they are solutions, then x1, y1 multiplied is equal to x2, y2. So we are going to solve, and we're going to assume that y varies inversely as x. And this is what your problem is going to look like. Y equals 5 when x is 12. Find x if y is 15. Well, we're going to take our product rule, x1, y1 equals x2, y2. We're going to plug in what we know, and we're going to solve that down. So 12 times 5, 60, 15x, divide both sides by 15, and we discover that x is 4. And that's all the notes that I have for you. I will see you in class. Let me know if you have any questions.